Hello and welcome to the section 1.3 lecture today. Today we're going to be talking about angles. So last time we talked about some segment stuff and some parts of lines, and we're going to kind of continue that, but more focus on the aspect of angles, okay, and some other kind of pieces. And so just to get us started here, I decided to start a little bit differently. And have us kind of read through some text to figure out some pieces of information that we need, rather than I write it, you write it. That gets old. But I also want to show you kind of a way that you can sort of mark up a text and just as you're reading something that you're given that you can write on. This wouldn't be like a school textbook, but later on in life, you'll probably have some books that you can then make marks in and do things like that. So let's go ahead and get started here. For the definition section here, it says that a ray is part of a line. The word that's important here is ray, so I'm going to go ahead and underline that. And you can as well. I would expect you to. This is officially your text that you can mark up. So it's part of a line. And that's kind of similar to yesterday, because yesterday we talked about line segments, which are we said a portion of a line, but portion, part, those mean the same thing. It's a piece of a line. So it says here that it has one endpoint and extends indefinitely. Now, maybe we're sort of unclear of what indefinitely means. And so usually if I come across a word I don't know, I'm going to circle that and then go to my teacher and say, hey, what does that mean? Or maybe that just reminds me, I should probably look that word up and kind of figure out some more common language that falls into and that helps me make sense of it. And we would find out that means like forever or non-ending. So this ray has one endpoint and then extends forever in one direction. It says here that rays are named by their starting endpoint first. Named by stating their endpoint first, then followed by any other point along the ray. So that kind of all that's important, but we're talking about how they're named and endpoint first and any other point kind of next, right? So all this is similar to like if you like using highlighters. You could use different colors for different things. It's kind of up to you. So then it says to draw and label a ray in this area below. So it says here that it starts at an endpoint and then it goes on forever in a single direction. So maybe something like that. I'm going to just throw some letters out here. It really doesn't matter. I'm going to use S for start, and it doesn't really finish, so I don't really want to use like a finish line. I'm just going to put P for point. Okay, and so that's a ray. It starts at a point, and then it continues on in one direction. Kind of the way that I think about a ray. Now, there's the obvious way of, I'll be kind of an elementary school teacher here for a second. If we got a sun and rays of light are coming out of the sun, they have a starting point, it's the sun, and they continue on, each one of them continues on in a specific direction. And that is what causes light at different locations. Okay, so that's kind of the basic of it. Geometrically, like object-wise, I think of it as just half a line. Now, if we think about that indefinitely, as in it wraps around the globe and comes back, eventually it's going to meet back up to this, but we don't really worry about that. So I think of it as half of a line. And that's kind of what I want you to think about. It's a half line. Good job hitting that button there. I think that's important to kind of get a visual of really what we're dealing with here. And then when it comes to naming it, right, it says that it's named by stating their endpoint first. So the endpoint of this is S, and then any other point along the ray. It can be any point that's out here. I have only one other one, and so I'm going to call that P. And then above it, this isn't stated up above, but it has a ray symbol, okay, a single-sided arrow. And the key here is that the endpoint is on the dead side of this line, and the point somewhere else is on the arrow side of this line, okay? And this would tell anybody else that this is a ray that starts at S because this side is blank. And I would say that we traditionally draw that arrow pointing to the right. And that's why it says stating their endpoint first. So even if it was going the other way, I would still, let's put another one on there, might as well. If I've got this ray here, that's, let's say that it starts at A and somewhere goes through B. I would still want to call this AB because it starts at A and it goes towards B. Okay, and that's pretty important of that order so that we understand that a little bit. The next part, we've got a whole nother round of kind of definitions, some just different pieces that we have in here. It says an angle, that's going to be the word that we work on defining. A very good underline there. An angle is formed by two non-collinear rays. That's a little overkill. All that part's saying, and maybe that part is kind of like, oh, what do they mean by that, right? That would be a good circle item. It just means, I'm going to put it over here in the margin, that I don't have this ray and then, let's use a different color here, and then this ray. Meaning they're not laying on top of each other, okay? And then it says that they have a common endpoint. That seems kind of important. I'm going to put a line under that. The rays form the sides of the angles, and the common endpoint is called the vertex. That's going to be important. Okay. So let's kind of look at another visualization, another diagram, and kind of put some markings on it also. So it says that an angle is formed by two non-collinear rays. So I'm going to try to fit it in here. I didn't give you much room to do it, but again, I'm trying to keep everything to one page. So those are two non-collinear rays, and I don't know, let's have a little fun with this, I guess. Let's put a D there, maybe an O there, and I like a G at that point. Spelling out dog. As we look at this, we have point O, that is the vertex. That is the common endpoint of the two rays. It's where they both start. Okay, and it's kind of the middle of the angle. And then these two rays are sometimes called the sides of the angle. I don't think that's as important as, as knowing what the vertex is. Now, what becomes a little bit important is when we get to naming angles. Now, there's a bunch of ways to name an angle. Number one, always, other than writing out the word angle, which doesn't seem very notation-y. It's not really a shorthand to writing it. So every way that involves a little angle symbol. Okay, it kind of looks like it's the start of a triangle, and it's always opening sort of to the right here. It's just the symbol that we use to say this is an angle. So one of the ways is to lay out all 3 points, and the order kind of matters. The letter that's in the middle has to be the vertex. So I have 2 options, and I'm going to stick with dog. And this O being in the middle is important to tell us that O is the vertex. Anybody could look at this and know, oh, that's an angle with vertex O. When it's totally obvious, as it is in this problem here, we could also call this just angle O. So the question is, when isn't that totally obvious? The only time that it's not totally obvious is if there's another angle that could be called angle O. If I had, I wish I would have drawn this the other way, but that's okay. If I had another ray coming out of point O, then it wouldn't be obvious what angle O is. But without that point there, without that point there, I think we're good to call it angle O. The last way that I'll say is a way to label angles is if you're given a little number inside. Now, there's two types of numbers that would be inside of an angle. This is an identification number. Okay, the other type of number that would be in there would be like an angle measure. And that would have some number of degrees. It might say like this is maybe 15 degrees. And they might have that in there, and then we wouldn't use that number. But if we have an identifying number in there, we could also call it just angle 1. Sometimes that becomes a little bit easier way to identify different angles. And you can add those numbers in there, even if they don't give them to you. Okay. And then we have 4 types of angles. Now here I actually want you to write a little bit. And not only that, but I want to give examples of all these. Okay, I think that's kind of important. So let's dive into what these are. The first one is an acute angle. Let me back up actually. Back up to up here. If I'm talking about the size of an angle, as I kind of already mentioned, I'll write out angle. I won't be that lazy. As I kind of already mentioned, we use degrees most of the time. There are other ways to do it also, but most of the time we're going to be using degrees to measure an angle. And we would find that using a protractor. It's really the main way of finding how big an angle is. And when we want to talk about the measure of this angled dog, and let's say it is 15. I made that number up. I don't know that it is. We would say in one of these 3 ways, I'm going to use the angle 1 method. We would say the measure, or M angle 1, that is kind of like the difference between the AB with the line over it and the AB that we talked about last time. This is just a number. This means we're going to say that it's something like 15 degrees. Okay. And that's going to be important as we get going here. Just talking about size of angles. Because the types of angles that we have are judged based on their size. Okay, and we can either be really picky and expect you to use a protractor to find the size of the angle, which I'm usually not because not many people buy protractors anymore. I'm more looking, can you visually look and tell me what kind of an angle it is? We have ways that we can get around issues of, well, maybe it is, maybe it isn't, I don't really know. We can find other ways around very slight changes. Acute angles, the first type, the requirement for it is that the measure of the angle, I'm going to use angle 1 for all of these, just so I can use some notation. Now, I will say in this angle notation, and I'm going to show you why it's important in a second, sometimes you'll see it like this, where they'll put this little arc in that angle. And I kind of need to do that. I think it's important today anyways. So let me just redo that. So when we want to say the measure of angle 1, if it's an acute angle, it has to be less than 90 degrees. That's a good reason why they put that little arc when they're talking about the angle. Otherwise, it could look like a less than symbol. Okay, so an acute angle measures less than 90 degrees. For an example, we just want something that's small. It's an acute little angle. I don't really want that on there. We're saying that's angle 1, and it has some measurement that's less than 90 degrees. A right angle, call this one angle 2, is equal to 90 degrees. Okay, and we've dealt with right angles in the past. Okay. That's usually noted by a square that's inside the angle to tell us that it's 90 degrees. Now this, for this example, is angle 2. An obtuse angle, let's move on to angle 3, is going to be greater than 90 degrees. For that, we look at something that is greater than 90 degrees. Let's call that one angle 3. And then a straight angle, I don't really like the term straight angle, but it comes up enough that we should know what it is without focusing on it too much. It builds a straight line, which means that its angle is equal to 180 degrees. And it would look like this. But that one's a little bit trickier. Well, no, I mean, it's pretty straightforward, but pretty straight, period. Okay, then the last kind of definition that we have, we talked about one of these yesterday, but we said it was the segment addition postulate. Today we're going to deal with the angle addition postulate, which just says that if I have a ray that's in between two other rays, so in this case, I have G that's in between DO and DS, then what does it say? Then the sum of the smaller angles adds up to the whole angle. Okay, part plus part equals whole. So if I say that I have angle 1 here and angle 2, actually I'm not going to use any of those. I'm going to use the 3-letter combination to make these. Okay. The main thing that I want us to see, especially in this picture, because I have points and everything, let's say the small one on top, let's call it ODG, measure of angle ODG plus the measure of angle GDS is equal to the measure of the whole angle, ODS. Okay, so very similar topic from yesterday. And that's the main thing that we're going to use today. We're also going to kind of classify some angles and talk about how big they are in a very general concept. Okay. So these first ones, I want to classify each indicated angle as acute, right, obtuse, or straight. Then I want to name the vertex and the sides of the angle, and I want to use good notation there. Angle 4, right here, looks like it could be a right angle, but I think it's a little bit bigger. If it's bigger than a right angle, it's obtuse. Okay. The vertex is point T, and the sides, I'll end up abbreviating these, TU and TS, they're rays. TU and TS. Okay. The next one is angle 1. Angle 1 is right here. That looks to me like it's an acute angle. The way I keep acute and obtuse straight is I think it's just a cute little angle. right? I know it sounds kind of cheesy, but that line right there makes statement makes me think that it has to be small. Yeah, I guess we're going to say capital V for vertex. The vertex of that angle is W, and the sides are WT and WV. Okay, and the next one, angle 2. This one's going to get a little weird at a couple spots, but that's okay. The angle 2, is less than 90 degrees. It would be a right angle if it went this way. Okay, and it doesn't. It goes above that. So that's going to be an acute angle. So that's acute. And we have vertex. This is where it's weird, V. And sides. We have VW and VT. Okay. The next one's angle 5. That's another acute angle. It's really small, so it's also acute. Its vertex is T, and its sides are TS and TW. Now we get into some 3-letter combinations. I'm going to try to mark these out a little bit. WTU, that's kind of the combination of angle 4 and angle 5. So it's right here, angle 4 and angle 5. It's an obtuse angle. It's a big one. So obtuse angle, its vertex is T, and its sides are TW and TU. The last one that we have is UTV. Let's try to highlight that one. UTV, it goes all the way there. Okay, and that builds pretty much what looks like a straight line. So I think we'll say that that is a straight angle. So notice we didn't have any right angles, but that's okay. So that's a straight angle. Its vertex is T, kind of a pretty common vertex in this problem. The sides that it has are TU and TV. The trick to that idea of saying what the vertex is and what the sides are, if you have it written in the 3-point notation, you know all that information. You know that T has to be the vertex, and you know that TU and TV have to be the sides. Okay. Let's wrap this up with a little talk on the segment addition postulate. Every one of these problems kind of sets up a new situation. Well, I say that kind of loosely. Kind of these two at the bottom, it says according to the previous problem. So those two are going to be related a little bit. All right, so let's dive into what it says. It says BA and BC, this one here and this one here are opposite rays. That means that's a straight angle. Okay, that would be a straight angle. And it also says that BD bisects EBC. So BD, and the term bisect means cuts in half. Okay, which, to get into our congruence marks or marking up a problem a little bit, that means that whatever this angle is, this one is the same size. And so we'll use one mark in each one of those angles. I don't know anything about these other two, so technically we'd say, well, this one could have 2 marks, and then this one could have 3 marks, right? Because I don't know any correlation between those two, but I know that these two are the same. Okay. So here it says FBE is 45. FBE is 45. I'm probably going to write on these and then erase them for all the different situations. And ABE is 100. Now, that one's kind of tough to mark, especially with those other marks in there. Let me get rid of some of this. We'll just remember that that angle bisects, or that ray bisects that other angle. So then this whole thing here is 100 degrees, is what that's saying. So what is ABF? So we're looking for this piece right here. Okay, let me grab yet another color. I want to know how big that is. Well, we would use angle addition postulate here, that the two smaller pieces, the one I don't know and the 45, have to add up to 100. So my question mark plus 45 equal 100. So do that however you need to, but it means my missing angle, or what we'll say is the, we'll actually write out what it is, the measure of angle ABF has to be 55. That's the missing piece between 45 and 100. Okay, I'm going to erase what I have in the diagram there because we're going to set up another scenario. It says if FBD is a right angle, so it measures 90 degrees, so we put a little elbow in there. And EDB, okay, that's written wrong. Let's say EBD, not EDB. So EBD is 35 degrees, so this one here is 35 degrees. How big is FBE? How big is this piece there? Okay, well, we can do that. That just means that the measure of angle FBE actually I'll say plus, not equals, plus 35, excuse me, has to equal 90. So what's the missing piece there? The measure of angle FBE has to equal, it looks like another 55. And again, this is going to happen a lot, that I'm going to give you one diagram and then set up different scenarios as we go. We notice in this next one it says if measure of angle ABE is 110. So before it was 100. Now I'm saying, well, let's say it's 110. I could give you different diagrams for each one of these, but that would just take way too much room. I want to know, what is angle EBC? So I'm looking for this angle EBC. Well, the first thing that the problem gave me is that ray BA and BC were opposite rays, meaning this is 180 degrees. If that's 110, the missing piece has to be 70 degrees. Okay. Then the last one says, according to this previous problem, what is the measure of angle DBC? So I know that this whole thing here is 70, and the second thing the whole setup told me was that this ray cuts this angle in half. So that means this part has to be 35, and this part has to be 35. So that's going to equal 35 degrees. Okay. So just using some of the things that we can know based on really intuition, I would say the angle addition postulate is a very basic tool. So get those done and have a great day. We'll see you in class.